Okay, now let's look at how the variable scopes may interact. I'm going to tell you about actually 4 variable scopes. We've looked at 2 so far. We looked at local and global. Now in this example, we're looking at a global variable and a local variable. And I want you to look closely at what the program is doing and see if you can predict what you're going to see when you run the code. Now, I'm not expecting you to necessarily know this. This is slightly speculative question. As you can see, we have a global variable var, and we're assigning the value 5 to it. Why don't we make this var a little different? Then we have a local variable var to which we're assigning the value 10,000 inside the function. Now, as you know, a local variable is going to disappear once we leave the function. It loses scope and it's no longer available. So here's the question. Obviously, when we run this code and we get to line 8 and we say outside function before call and we're printing var, we should see 5. That makes sense. Then we're calling do and we're assigning a local variable to the same name as the global. Now, the variable on line 5 is local. We're assigning to var inside the function. That makes it local, which means that the value 10,000 will no longer be available once we're outside the function. So here's the nut of it. On line 12, we're printing var. What will we see? And I guess you can only imagine that there might be 2 possibilities, but I'm going to give you a chance to look at it if you will hit pause, and we'll go over the answer once we return. All right, let's take a look at what happens. Now, before we do, I would like to tell you about the 2 possibilities that I see if I hadn't seen this before. I know from what I've just told myself and told you that on line 5, because we've assigned 10,000 to var inside the function, we know that that 10,000 will not be available outside the function. It can't be. That's because it's a local variable. So the big question, which is what we'll see when we print line 12, I think has 2 possible answers given what we know. One is that var will be undefined at that point because var got overwritten on line 5. Then var will be undefined when we get to line 12. The other possibility is that var never got overwritten really. And that the global var is a different var than the local var. Let's find out what happens. Okay, so outside the function we see 5, great, that makes perfect sense. Inside the function we see 10,000, that also makes perfect sense. But when we get back out of the function, the local var from line 5 disappears because it's scoped to the function. And when we get outside, the global var returns. It never really went away. It was just being masked by the local. So on line 6, when we printed var, if we had not assigned 10,000 to line 5, I think we know that since var is a global, we would see it. That is, once we remove the local variable altogether, we see that the print statement on line 6 refers to the global var, and that makes sense too. The global var 5 will be available everywhere, both before the function, outside the function, and inside the function. But when we assign to the local variable, we do have a local version of var or a local variable called var. Once that disappears though, once we get outside the function, the original var returns to visibility. What that means is that the local var temporarily masked the global var. Now, this isn't something that we normally have to think about because normally the variables inside our functions are named differently. But even if they weren't, the only time we would have a problem is if we wanted to refer to the global var inside a function where we had already reassigned var locally. That is, if we sort of wanted both the global and the local to coexist. If we really wanted that, of course, we would probably just rename our local variable and we'd be fine with either one. We could print them both and we would have no problem. But that's not what we're talking about. What we're really trying to talk about is the availability of variables and how they interact. And that brings us to one third scope that I want to talk about, and that's the scope called built-in, the built-in scope. Now remember, when we're talking about scopes, we're talking about names. Local names assigned inside the function, global names assigned outside the function, and then we also have a third category of names that you've seen many times before that we call built-in. And I hope, well, if you think about it for a second, and you may want to pause, ask yourself what names that we've seen many times before would be collected under the name built-in. Okay, the answer is variables like len. So if I print the len of hello, I'm going to see 5. That's my favorite example. I can't ever seem to get away with it. Get away from it. 1, 2, 3, 4, 5, 6, 7. Let's say goodbye will get us 7. And what is that telling us? The name len is also a name. It's also a variable. It's also a name that we refer to. And names like print, len, round, type, exit, all of these functions refer to built-in names. The only names that really don't refer to actual built-in names are things like def. Def is more of a statement. If, elif, else, these are statements. While, that's a statement. There are a number of other statements in Python, and you can tell because they're being used without parentheses, so they're not functions really. They're statement syntax entities. So that's not something we really have to worry too much about. What we want to think about is these built-in names, because the built-in names can also be overwritten. In the same way that we have a var that is both local and global, and we saw that the local name overwrote the built-in name, the same thing would be true if we attempted to reassign the value of a built-in. Now this is a little nutty, because if we were to just choose the name len, we could use it if we wished. And so we're going to see the same effect here because we're using the name len. Now, what's really odd about this is that len is a built-in function. Len is a built-in name. And so that means that what that means is that when we overwrite it, it's not going to be useful to us as a function anymore. And this really was one of the very first things I learned about Python, and I was a little surprised when I saw it. What do you suppose is going to be happening when I decide to use the word len? Now you may say, oh, well, len is a function, so when I try to use it as a function, it'll work like a function. But no, len is a name. Len is a name in the built-in scope, and in fact, if we try to use it like a function, but it's been assigned an integer, we get an error that basically tells us that int object is not callable. What does callable mean? Well, you know what a function call is. It's when we call a function. That's what we're attempting to do here. But we're not calling a function anymore. We're calling an integer. Len has been assigned as an integer. We're allowed to reassign the names of built-ins. Now, some folks would argue with this and say, this is really weird. Why would Python allow us to overwrite the name of something that's so central to its, most often used features? And it is. We use len all the livelong day. So reassigning len, why doesn't it stop us? It ought to just stop us right there and say, len is a built-in name, cannot overwrite. but Python doesn't stop us. Now, I haven't gotten a great answer to that question, but I do believe that part of the motivation may have been so that all names will be treated equally. All names will be treated in the same way. Now, it is true that local, global, and built-in, and len is part of the built-in scope. Local, global, and built-in are different scopes, and they are handled a little bit differently. For example, built-in names are always available no matter what you do, no matter where you are. And in fact, they're available in multiple files and in different files. They'll always be available. They don't have to be assigned. Globals, of course, have to be assigned before they're used. They're also available everywhere in a file, but they don't have to be, they need to be assigned before they're used. Locals, of course, have to be assigned and used within the same function. And that's how locals work. So these three names, scopes, are what I want you to understand and be able to use. You don't really need to know much more about built-ins aside from that they are just a third type of scope, that they're always available no matter what, and that they could be renamed. Now, usually this doesn't even cause us a problem. This is more of an academic distinction. It's not something we have to think about that hard. The truth is you might at some point try to assign a variable to len, but fortunately, if you then later on try to use the len function and it tells you something like int object is not callable, you should at least understand what that message means. It means that we're trying to call len, and len is no longer the function that we thought it was. It is, in fact, an int. Again, we don't really normally do this, and it's not something that causes us a problem usually, because normally we're aware of what we're doing, or if we're not, Python tells us right away. Obviously, if I never used the len function, I wouldn't have a problem using the len name, and Python doesn't really have a problem with it either. As far as the fourth scope goes, this is a little more advanced and something we don't normally need to think too much about, but there is a way to define a function inside inside another function. And if we do that, it's important to understand that it's another variable being assigned inside a function, do this, which is basically a local variable now. Do would be a global, and do this would be local because it's been defined inside the function. And when we have a scope in which we're referring to a variable that was defined inside an outer function, we call that enclosing scope. But as I say, this is far more advanced material and not something we have to think about at all. Those are the four scopes, however: local, global, built-in, and enclosing.